This is section 3.1, part B, displaying and interpreting scatterplots. The most useful graph for displaying the relationship between two quantitative variables is a scatterplot. A scatterplot shows the relationship between two quantitative variables measured on the same individuals. The values of one variable appear on the horizontal axis, and the values of the other variable appear on the vertical axis. Each individual in the data appear as a point on the graph. So the point that is highlighted in the graph on the left represents Colorado. In Colorado, 21% of the students took the SAT, and their mean SAT math score was 570. So how do you make a scatter plot? First, you need to decide which variable should be on each axis. Always plot the explanatory variable on the horizontal axis, or the x-axis. A helpful hint is explanatory has an x in it, so you put it on the x-axis. If there is no explanatory response distinction, either variable can be put on the horizontal axis. Make sure you label and you scale each axis, and then plot individual data values. 9th grade students at the Webb schools go on a backpacking trip each fall. Students are divided into hiking groups of size 8 by selecting names from a hat. Before leaving, students in their backpacks are weighed. Here are data from one hiking group in the recent year. So make a scatter plot of the relationship between body weight and pack weight. Now, you may assume that depending on how much a person weighs will determine how much they put into their backpack. So if we were to make a scatter plot, if the body weight explains the pack weight, you would put the body weight on the bottom, and you would put the pack weight on the side. Now you would go through and you would make your scale for your scatter plot, and you would label. And then for each person, you would put a dot. So if we look at this scatter plot, we have the scale along the bottom. It's going from 100 to 190. The pack weight is going from 20 to 36. And we would plot each point. So this point right here represents the person who weighs 120 pounds and whose pack weighs 26 pounds. To interpret a scatter plot, follow the basic strategy of data analysis from chapters 1 and 2. You're going to look for patterns and important deviations from those patterns. So you need to check the graph for direction. The two variables can either be positively associated or negatively associated. You will have a positive association when above average values on one tend to accompany above average values on the other, or if the graph goes up towards the right. If two variables have a negative association, then you have above average values on one accompanied with below average values on the other, or the points go down to the right. So positive, they're going to go up to the right. Negative, they're going to go down to the right. You're going to check the graph for the form. So you're going to determine if the scatter plot is straight, if it's curved, or if there is no form to the points. Also, you need to see if there are any clusters or groups of points that are away from the other clusters. You're going to check the graph for the strength. The strength of a relationship in a scatter plot is determined by how closely the points follow a clear form. And then you're going to check for any outliers. So we're going to describe the scatter plot. To do this, we're going to describe the direction, the form, the strength, and any outliers. So if you look at this graph, the graph has an overall pattern that moves from the upper left to the lower right. So this means the states in which they have a higher percent of high school graduates taking the SAT tend to have a lower SAT average math score. So if we look, this is what percent of students took the SAT. So if like 90%, probably about 87% of the state, they took the SAT score. Their average SAT score is much lower Then the schools who had few students who took it, those scores are higher. The form of the relationship is slightly curved. If you look, this is a little curve to this shape. Most states fall into one of two distinct clusters. In about half of the states, 25% or fewer of the graduates took the SAT. So here's one cluster. Another cluster is over here. So in the other half, more than 40% took the SAT. Now the overall relationship in the graph is moderately strong. So those points tend to stay together. States with similar percent that took the SAT have roughly similar mean SAT scores. Two states stand out in the scatter plot. West Virginia, that was at 19%, and only had a mean score of 501, and Maine, which had 87% and only had a mean score of 466. These 2 points fall outside the overall pattern. So in the previous example, we constructed the scatter plot that was shown below. This was the body weight with the pack weight for the hikers. We need to describe what the scatter plot reveals about the relationship between body weight and pack weight. So it appears that the lighter students are carrying lighter backpacks in general. We say that this has a positive association between the two variables because as the explanatory variables get higher, the response variables also get higher. There seems to be somewhat a linear pattern to the graph. These do tend to fall in a line. Since the points vary somewhat from the linear pattern, the relationship is only moderately strong. If all those points would have been a very good line, we would say there was a strong association. We can see one possible outlier in the graph. It's the hiker that has a body weight of 187 pounds and a pack weight of only 30 pounds. He seems to be carrying less relative to his body weight than any other member of his group. Manatees are large, gentle, slow-moving creatures found along the coast of Florida. Many manatees are injured or killed by boats. The table below contains data of the number of boats registered in Florida in thousands and the number of manatees killed by boats for years from 1997 to 2007. We need to follow the four-step process. So remember, when you're following the four-step process, the first thing you need to do is state what your question is. So our state could be, what is the relationship between the number of manatees killed and the number of registered boats? Now we need to come up with a plan. So our plan can be that we'll make a scatter plot of boats registered as the explanatory variable and manatees killed as our response variable. Then we will describe the direction, form, and strength of the relationship and identify any possible outliers. So when we do this, for the do part, you will actually make your scatter plot, and then we'll look to see about all the stuff we can describe with the scatter plot. So there seems to be a positive association, which means the more boats that are registered, the more manatees that are killed. The form does seem to be linear. It is going from the lower left to the upper right. The relationship is pretty strong. They are pretty close to that line. And there does not appear to be any outliers. So now we need to make a conclusion. So our conclusion could be, as more boats are registered, the number of manatees killed by boats goes up linearly. Now, the previous example described an important caution. Association does not imply causation. So just because we can see that there is an association between numbers of boats registered and the number of manatees that were killed does not mean the number of boats going up is causing more manatees to be killed. Always ask what other variables lurking in the background might contribute to the relationship between the two variables. For example, if boats in Florida had tended to go faster over the years, This might result in more manatees killed by the same number of boats. Now, you can use your graphing calculator to create a scatter plot. To do this, you're going to enter your data values into your list. You'll put your explanatory variables in list 1 and your response variable into list 2. You're going to define a scatter plot by hitting second y equals to go to your plot. You're going to turn plot 1 on. You will select scatter plot. You can change what mark you want to make, but you do need to make sure that your X list is list 1 and your Y list is list 2. Notice that if you graph this, you're going to hit zoom and then zoom stat, which is number 9. On your graph, on your calculator, there's not going to be any scales on the axes, and the axes themselves are not going to be labeled. So if you copy the scatter plot onto your paper, make sure that you add the scale and label your axes appropriately. So here's a scatter plot that plots the interval between consecutive eruptions of Old Faithful against the duration of the previous eruption for 1 month. Describe the direction of the relationship. Explain why this makes sense. So the relationship is positive. This means that the longer the duration of the previous eruption, the longer the wait has to be before the next eruption. This should make sense because it took so much energy for the eruption because it was so long that it's going to take longer for it to build up to have another eruption. What form does the relationship take, and why are there 2 clusters of points? The form is roughly linear, but it does have 2 clusters. The clusters indicate that in general there are 2 types of eruptions. One of them is going to be short eruptions that have another eruption happening very shortly afterwards. And then the other type of eruption are eruptions that are much longer, but then will take much longer for the next eruption to occur. How strong is the relationship? And we need to justify our answer. The relationship for this association is fairly strong. 2 points define a linear, and in this case, we could think of each cluster as a point. So we can think of this as 1 point and this as another point, and we can create a line between 2 points. So the 2 clusters seem to define our line. Are there any outliers? There are a few outliers around the clusters. If you notice, there's some stuff that's hanging around the outsides. Those would all be outliers to the data set. What information do the Starnes family need to predict when the next eruption will occur? To be able to predict when the next eruption will occur, they will have to know how long the previous eruption was.